All right, welcome everyone. In this video, I want to pick up with handling the special case that we ran into in the previous example, which is when we have two observations in our data set that are located at the same point, then it's having an issue identifying which are the nearest neighbors. Should I include the element itself as its nearest neighbor or not? So we had this issue with the iris data frame that observation 1 and observation 2 had the same petal dimensions. So they're distance 0 from each other. And that meant when we ran this algorithm, we created a for loop, and this for loop created a list. Each element of that list is a vector of 3 things, and that vector tells us the 3 other observations that are closest to it. But when we looked to find the nearest neighbors to observation 2, we found that 2 itself was its nearest neighbor, and we don't include the observation itself as a neighbor. That's not a neighbor to itself. So in this case, we would want this entry of the list to indicate that the 3 closest elements or observations that are closest to 2 would be observation 1, observation 5, and observation 9. So this for loop is not handling that special case. But we can incorporate that with an if-else statement. So I'm going to run the same exact loop that we did in the previous video. So we're going to run this as I goes from 1 up to 150, which is the length of our list, and it also happens to be the number of rows of our data frame. Then what we're going to do is we're going to take that matrix D, which included all of the distances between pairs of points, and I'm going to pull off row I of that matrix, which tells me how far all of the other observations are to object I. And then we apply the order function to that, and that's going to tell me which element is closest, second closest, third closest, and fourth closest. And so what should happen is that the closest element to I should be element I itself. So we can kind of go back over here and see what happens when we create these vectors like this. So for row 2, let me take a look at what that looks like. Like the first 4 elements are 1, 2, 5, 9. And if I take a look at a similar thing, we've already created OD1. This is telling me the 4 closest elements to 1. So this looks good. The closest element to 1 should be 1 itself. I don't want to include that as a nearest neighbor, so I pull off the elements 2, 3, and 4 from this vector. And this is going to indicate the 3 nearest neighbors are 2, 5, and 9. With observation 2, we have this issue that it's kind of messing up which thing to list first and which thing to list second. So if it happened to list 2 first and then 1 second, that's what we would want. So we really would want to see this as 2, 1, 5, 9, because 2 should be closest to itself. But what we're seeing here is that the distance from 2 to both 1 and 2, both of those distances are 0. So it listed 1 first, and then 2, and then 5, and then 9. So from this vector, in this special case, I actually don't want to extract values 2, 3, and 4. I want to extract values 1, 3, and 4. So I can encode that with an if-else statement. So what I'm saying here is if the first element of that ordered vector is not equal to itself, which is the case over here, then rather than pull off elements 2, 3, and 4, tell me what that first element is because that's the closest thing. Then you can skip over the next one, and then you can identify um, 3 and 4. However, if this is not true, then that means the first element listed in terms of ranking the nearest neighbors is itself. That's great. So in that case, yes, just tell me 2, 3, and 4. So that's going to handle these two cases differently. In a case like this, where the first number is not equal to 2, then we want this first number and 3 and 4. In other cases where the first number in our list is equal to the observation number, then we skip that one and we just pull off 2, 3, and 4. So this is kind of what we would do in most cases, but there might be some special cases, and that's how we can handle them. And yeah, you can think about, well, what would happen if there were 3 things that all were equidistant from each other? That doesn't happen in this data set, but you could account for that similarly with an else if or something like that. So now when I check my first 3 entries in the list, it's telling me that object 1 or observation 1, the nearest neighbors are 2, 5, and 9. Observation 2, it's no longer saying the nearest neighbors are 2, 5, and 9. Now we're correctly getting the information that objects 1, 5, and 9 are closest to that. So that's how we could fix that for loop from the previous video to handle this case where we have a pair of observations that have the exact same dimension.